Okay, dear students, we welcome you to the 10th HVAC lecture, which is put in the YouTube for your reference. In this lecture, we will be covering varieties of topics. We are coming to the end of the syllabus. We will be covering varieties of the topics which we covered here. The first one is the diameter of chilled water and condensed water pipes. Diameter of chilled water and condenser water pipes. Remember, this CHW means chilled water, CTW means condensed water. This is a general industrial specification of writing these two types of pipes. In exam, I will be writing the full name. In the exam question paper, if I give the question, the chilled water and condenser water, I will write it. But here, for your reference, you should remember CHW is chilled water, CTW is condenser water pipes. Because you have shown tremendous interest in my YouTube lecture, I am preparing every lecture slide separately and then uploading in the video and then giving you the links to it. You have already shown your interest in seeing my YouTube lectures, and you find it is very clear the way I explain. So I am also concentrating into YouTube lectures so that you can read it through. During exam, even you may not read. You go through my lectures and you will get all the answers. You see my drawings and I explain the drawings accordingly. The diameter of chilled water and condensed water pipes. There are two systems, open system and another is closed system. This is chart. Here is GPM. GPM is gallons per minute. Here are the curves showing velocity. I have removed it to make it clear what is written here. You can see it clearly. Pressure drop feet per 100 feet. This is velocity in FPS. FPS means feet per second. This diameter 2 inch, 4 inch, 6 inch, 8 inch, 10 inch, 12 inch, 14 inch. These are diameters in inch. There are two systems here in finding out the diameter of pipe. One is closed system, another is open system. You should be able to find out the difference between the open system and closed system. In open system, it is used for condenser water piping. Open system is for condenser water. Closed system is for chilled water. Why closed and open system is there? You can yourself find. In case of condenser water system, the water goes from condenser to cooling tower. I showed you in the last class how it goes to cooling tower. Cooling tower is an open system, open to atmosphere. There is a blower. Through the blower it is open to atmosphere and air goes up from there. So, it follows the chart which is open system chart. In case of closed water piping, that is chilled water system, there is nothing open here. Water goes from chilling machine, that is evaporator of the chilling machine, to the HU, and from HU it comes back to the chilling machine. HU is a closed system, it goes to the cooling coil and comes back, and there is no open system in that. So in case of chilled water piping, we are using closed system of chart. In case of condensed water piping, we are using open system of chart. The charts are same in parameters, but the dimensions are different. Try to understand what I am telling. Charts are same in parameters, but dimensions are different. That means the open system chart is different, the closed system chart is different, but it is made in the same way. What I mean to say, this is US GPM, this is US GPM. US GPM is United States gallons per minute. There are two types of GPM, gallons per minute. One is UK GPM you follow or US GPM. In India, we follow US GPM system. GPM is gallons per minute. That is the volume flow rate. It is all in FPS system. I told you the air conditioning system, HVAC system is designed as per FPS system because the US follows the FPS system. So in India we follow FPS system. So following this FPS system, this is US GPM, gallons per minute, and this is pressure drop, feet per 100 feet. You understand? When water is flowing through the pipe, as it flows through the pipe, there is friction, and because of friction and resistance, there will be pressure drop in the pipe. So this x-axis will give you the pressure drop in feet per 100 feet. I mean, per 100 feet कितना pressure drop हो रहा है, that they will be telling. Per 100 feet में कितना pressure drop हो रहा है, feet per 100 feet. And this is US gallons per minute. How much water is flowing? What is the flow rate of water in US GPM, United States gallons per minute? There is the volume flow rate is given here. Other than that, here is the velocity. These all are velocity. These all are velocity. I have written velocity. You can see in FPS, feet per second. And I have written diameter in inches. Carrier handbook, what I have referred you can go through that, you get these charts. But this is a preliminary elective subject HVAC class. You need not calculate the details of the piping diameter, but you can see how the charts are being used. You should have an idea of how it is calculated. Because there are so many things in your syllabus to give you a big overview of the subject that separate piping design, ducting design requires a separate BTech subject for HVAC. Where HVAC specialization is given separately, there these things are taught. You need to know how the charts are used. These are the charts. These charts are this feet per 100 feet and this is velocity. These are diameters 2 inch, 4 inch, 6 inch, 8 inch, 10 inch, 12 inch. I have written diameter in inch. 2 inch means 50 dia pipe, 4 inch means 100 dia pipe, 6 inch means 150 dia pipe, 8 inch means 200 dia pipe, 10 means 250 dia pipe. 1 inch is equal to 25.4 mm. You remember 1 inch is equal to 25.4 mm. So you can under 100 dia pipe, 2 inch means 2 into 25.4. This is 50 dia pipe. 50 mm diameter pipe. 50 dia pipe means 50 mm diameter pipe. 4 inch means 100 mm diameter pipe. 4 into 25, that is 1 inch is 25.4, that is 100 mm diameter pipe. 6 inch is 150 mm diameter pipe. So, for every pressure drop and every US GPM, we have a particular diameter of pipe. So, when you choose the diameter of the pipe, you also know what is pressure drop happening in the system. And how the pressure drop will come into effect? When you design the chilled water pipe or condenser water pipe. I showed you in chilled water pipe and condenser water pipe what factors you are taking to calculate different drops. So this pressure drop comes there into effect. To understand how it is working to find out the pressure drops of different chilled water pipes and condenser water pipes at different diameters. This is all about the calculating the open system and closed system water diameters, the pipe diameters of the condenser water flow and chilled water flow. This is what is calculated through. Just giving you the diameter of chilled water and condenser water pipes. You should remember this class. You can see this class before going to exam. You will remember how the diameter of the pipe is formed. It's very easy. This is now I will be talking about plant room location and HO room location. Plant room location. Now, I have plant room and HU room location given here. This is the HU room location. In the HU location, this is the plan. This is the plan. Plan of a building, total building. Now, HU I have shown you in the drawing. HU remains in HU room, and HU room should have proper fresh air supply. Try to understand, proper fresh air supply. So it is generally, it should be like that. It should be existing at the corner and the free area of the building. Ideally speaking. But if you don't get an HU room at the free area of the building, there is alternative arrangement also that I will be talking you. But as a typical or ideal case in a building like that, HU room should be here, or HU room should be here, or HU room should be here, or HU room should be here. So that fresh air can be taken from here, fresh air can be taken from here, fresh air can be taken from here, 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 and here. We know that in HU room we make a mixture of return air and fresh air. To make that mixture, we need the HU rooms to be taken at the corners of the building. If the building is rectangular or square. But in some cases, the HU may not get a proper place of HU. Maybe HU room is being given somewhere here. Somewhere in the middle of the building or somewhere in the near. What do you do? In that case, you take a duct, fresh air duct from this part. From here the air enters there and goes to the HU room. But this is not an ideal solution. It is not an ideal solution. Ideally speaking, HU room should be at the corners of the building. Location of HU room is very important. I have already shown you what should be the HU room dimensions. So these HU rooms not only have dimensions, you have to fix its location in the architecture drawing. At the beginning of HVAC, beginning of the building drawing, the architecture first prepares a design drawing. That is also called NIT drawing. That is not an inviting tender drawing. That is standard drawing. In that, he shows an approximate location of HU rooms. How he does that? He takes help of an HVAC engineer, calls him at the design stage, and makes the HU rooms through him. Because HU room cannot be made by an architect. An architect does not know how to design an HU room. He is not a mechanical engineer. And for a mechanical engineer only, it is possible to know what is the heat load, that is what is the CFM and tonnage of a building, and depending on that, he will fix the size of HU, and depending on that, the HU room will be fixed. So these are different dimensions of the HU rooms being shown here. The HU room nowadays, as per fire standard, HU rooms for the same floor should be located in the same floor only. That means one HU should not supply to the other floors. This is the latest fire standard in case of commercial buildings. Commercial buildings, not for residences. That means earlier we used to take one HU at the basement and used to supply all the floors to the same HU if the building is not very big one. But now it is against the decorum of fire standard because fire can spread immediately from the basement to all the floors. I told you in the fire damper drawing when I was doing in the earlier chapters, that is chapter number 3, the how, that is unit 3, that how the fire spreads by fire damper in case of HU room. So for that reason, the fire department has standardized that HU in that floor will supply that floor only and should not supply the other floors, so that there is no transmission of fire to the other floors by the HU in case of a fire hazard happens. And you know fire hazards happen every now and then in places in big cities like Delhi, Kolkata and Chennai and Mumbai. There are, after every few days you listen these stories of death due to fire in the building, and all fires are happening due to HU ducts because of the air conditioning system and by the air handling unit. So this is a very critical matter nowadays. That HU taken here should supply to this floor only, and you should not puncture the roof. You should not puncture the roof, and you should not go through the roof to the other floor. It should not go. This is strictly prohibited as per fire standard in case of commercial buildings, shopping malls, etc. And this regulation is getting tighter by every day because of so many fire hazards and fire incidents happening. If you make HU room only one at the basement and try to supply the whole floor, the fire department won't pass your drawing. Then comes plant room. Where is the location of plant room? Plant room is the place where the chilling machine is located, the chilled water pump is located, the condenser water pump is located. Chilling machine, chilled water pump, condenser water pump. Other than that, the big chilled water pipes, the big condenser water pipes. Remember, at the plant room, the size of the pipes are very big. At the plant room, the size of the pipes are very big and you have to accommodate that within the plant room. So generally, plant room is fixed at the ground floor. But where there is lack of space, we are placing the plant room sometimes on the rooftop also of a building. But if you provided the rooftop, then it should be having many things. One is the roof should be made vibration free. That means the civil engineer should design the structural drawing in such a way that the roof is almost vibration free. There's heavy RCC, heavy beams and heavy structure is to be in place. So that, because when the chilling machine runs, there is a lot of vibration in the chilling. Chilling machines are very big ones. These are 200 ton, 300 ton, 1000 ton chilling machine. In your home, what type of air conditioner you have? 1 ton, 1.5 ton, 2 ton, 2.5 ton, maximum 3 ton. And I am talking of 1000 ton chilling machine. You can see the difference in the capacity. 1000 ton chilling machine placed on the rooftop provides a tremendous amount of vibration. Not only vibration, the roof may collapse also if not properly designed. Because chilling machines have a terrific weight. So it should be properly designed. The chilling machine should be properly designed in that case. That chilling machine, after properly designed at the rooftop, you can place, but provided the architecture should be instructed to make the roof capable enough to take the chilling machine, and that he should provide this direction to the civil engineer who is constructing the roof. This is a very important phenomenon, remember. Number one, it should be vibration free. Number two, it should be noise free. Here at the roof, this is the building, this is the different floors of the building. Here at the roof you have the chilling machine. Here is the office. And chilling machine starts vibrating and sound goes to the office. What happens? You don't listen what is happening in the, how can you work in the office where there is a continuous humming sound of chilling machine? Not only the humming sound, also the vibration sound of the chilling machine should not come to the office. So it should be noise free. It is totally responsibility of civil engineers to design it like that. That increases the cost of the client. So generally, the rooftop is avoided, but in places which are congested places like our shopping malls and all these things, and in congested places that you don't get space, they're placing the chilling machines on the rooftop even, especially air-cooled ones. You know, I told you about air-cooled and water-cooled. Water-cooled is cooling water, and air-cooled is with fan. So big chilling machines, which are air-cooled ones, can be easily placed in the rooftop with proper designing of the roof. But chilling machine with water-cooled system generally preferred at the ground level only. These are the locations of HE rooms and chilling machines. Then we have foundation of chilling machine. Foundation of chilling machine. This MC means machine. Remember, MC, M/C means machine. This is shortcut form. In exam questions, I will be writing full machine, MACHINE. Don't worry. This is in drawing. These types of forms are generally used. Now, this is how the chilling machine foundation is made. Chilling machine foundation, these are the stands of the chilling machine on which the chilling machine does. This is the floor level. This is the floor level. This is symbol of floor level. I am doing this symbol of floor level. This floor. This is RCC structure. I have written already. This is RCC structure. In that, a screw comes. The screw comes through, enters to it is punched into the RCC structure, and the RCC structure is filled up. In between that, there is vibration pad. This is vibration. So, chilled water, when chilling machine vibrates like this, the vibration takes the vibration, and through these punctured a steel screw which remains inserted in the RCC structure. So, this is the foundation drawing of the chilling machine. Chilling machine is generally placed in such a solid foundation in the structure. This is a solid foundation of the structure where the chilling machine is being placed. This is general cement concrete floor, but this is reinforced cement concrete. This is RCC structure. There is a difference between cement concrete and reinforced cement concrete. A civil engineer understands that. RCC structure is much more stronger as compared to simple cement concrete. They provide steel insertions in between in the RCC structure, the insertions of metals, insertions of concrete, and they make the structure very tight. So that this vibration is transmitted, say it is a floor, it is a roof floor, then this vibration transmitted here should be very less vibration should be transmitted here. That I told in the last lecture, this lecture only, I was talking about this vibration should be transmitted in very less. This is how the foundation of chilling machine is made. This is foundation structure of chilling machine. With this, I come to the end of 10th lecture. The syllabus